Okay, in this video we are looking at two different types of isoquants which do not look like the conventional isoquants that we have seen in the previous video. So what is different about these isoquants? Well, again, remember that the slope of the isoquant tells us something about the flexibility with which inputs can be substituted. So for instance, this isoquant map, we have straight line isoquants, right? So we are measuring L, labor on the horizontal axis, K on the vertical axis. So combinations of K and L produce Q0 and then Q1 and Q2 levels of output, right? They are straight lines, means that the slope is the same at all points, or in other words, delta K over delta L, the slope is constant, right? It is constant. That means MRT as L for K is constant. Now you could think of this as an example would be, if, for instance, in a dessert recipe, if you are able to replace 1 teaspoon of sugar with exactly 1 teaspoon of honey, right? Or you can replace 1 teaspoon of sugar with 2 teaspoons of honey every time. So that would be an example of perfect substitutes. On the other end, we have a fixed proportion production function where the isoquants are L-shaped. So again, since these are isoquants, we are measuring labor and capital, but they are L-shaped. That means if you increase, so suppose you have K0, L0, okay, combination produces Q0. If you keep K0 fixed at K0 and just increase L0, then you're not able to change output. Similarly, if you keep L0 fixed at L0 and just increase K0, you cannot increase the output. So they always have to be used in a fixed proportion. Okay, an example would be the mixed grain cereals, for instance, where raisins and let's say sunflower seeds and oats, they're mixed up in particular proportions, and they will always have to be mixed up in that particular proportion, so they're not substitutable. So these are the two special types of isoquants. In the lower panel, we show the isoquants and how they are spaced depending on returns to scale. So this relates to really the technology of production. Okay. On the first graph, we have something called increasing returns to scale, or IRS, which basically shows that if K and L are both increased by a certain proportion, by the same proportion, then output increases by more than that proportion. Okay, so when we talk about returns to scale, it is, remember two things. Number one, it is a long run phenomenon. Number two, it means both inputs, all the inputs are changed, okay, increased or decreased, as opposed to returns to factor, which is a short run phenomenon where one factor is kept unchanged and the quantity of the other factor is changed. Okay, so coming back to increasing returns to scale, so how do we draw the isoquants for an increasing returns to scale technology? So here is how we draw that. We measure L and K, right? So Q0 is, let's say we start with the isoquant Q0, and K0 and L0, some quantity of K and some quantity of L yield Q0. Now let's say K increases to 2Ks. Okay, so capital is doubled and so is labor. So both capital and labor are increased by the same proportion, both are doubled. Now if this is an increasing returns to scale production function, then quantity of output will more than double. Okay, so increasing returns to both the factors of production. That means if we have 2k0, which is twice this distance, and 2l0, which is twice the distance l0, then the isoquant that will pass through this point will be output level which is higher than 2q0. This is what IRS is. That means the isoquant which shows 2q0 will lie below this dotted isoquant. So in increasing returns to scale, the isoquants will be more closely spaced, okay, that relate to equiproportional increases in both factors. Similarly, constant returns to scale. Note that here 2k0 and 2l0 yield exactly double the output. So the isoquant 2q0 will pass through this point. All right. So this constant returns to scale. Decreasing returns to scale, the name suggests, k doubled, l also doubled, but output will less than double. So output increases, but by less than 2q, which means this 2k0 and 2l0 point, right, will lie below. So they yield less than 2q0. So in order to double the output, we would need to more than double the inputs. So these are, the three different types of isoquants based on the returns to scale. And as we will see later on, that the constant returns to scale is a very widely used production function. It is very easy to work with mathematically, and we will see examples of that later on.